So welcome back to another set of theory topics for A-level computer science. Today we're going to look at data representation. We've got a full series going through every single bit of maths that we need to know for H446 OCR A-level computer science. And today we're going to look at binary conversions. So before we do binary, we need to know what is denary, which is our everyday numbers that we use. Technically it's the Arabic system, hence why I read it from right to left, and we've got units, tens, hundreds and thousands, so this number on screen is 5,921. Should learn that in like year 1, so I don't think we'll cover that too much. Binary, however, uses base 2 rather than base 10, which means instead of 1, 2, 3, 4, 5 and so on, going for your units, tens, thousands, hundreds, all that stuff, we actually go by 2. So we go 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and that can go on as long as the number is big. You know, you can go up to 256, 512, 1024, it just keeps going. Okay? So to convert a binary number to denary, what we do is if there's a 1 in that placeholder, we add it. So 1 plus 4 is 5, plus 8 equals 13. Really simple, binary to denary. However, if we're converting denary to binary, it can be a little bit more tricky. So there's 2 different ways of doing it, and it depends how confident you are when you're doing your maths essentially. So personally, I think the subtraction method is slower, but possibly less chance of failure, less chance to mess it up. Whereas the division method, which we're going to look at on the next slide, a little bit different, but you've got to do a lot of dividing. So we take a number such as 74, so we're converting 74 in denary to binary. So can we take away 74, so 128, sorry, from 74? No, we can't, because it wouldn't be a positive number. So we would put a 0, and then what we'd do is move on to the next number. So we'll put a 0 in there. I'm not very good with my mouse, so bear with me. So can we do 74 take away 64? Yes, we can. So we put a 1 in that column, and we subtract. We've now got 10 take away 32. Well, that would be a negative number. Same with 16. But we could subtract 8, so we can put a 1 in there, which means 2 is going to be left over. 2 take away 4 would be negative. However, 2 take away 2 would be 0, which counts as positive. So that can be a 1. And then the final number would be a 0. So 74 in binary would be 0, 1, 0, 0, 1, 0, 1, 0, because 2 plus 8 equals 10, and 10 plus 64 equals 74. The second method uses division. So we're going to convert a number 9. So 9 take away 2 equals 4.5. Okay, so we take the whole number, and then if you've got a decimal, we times that by 2 to get the remainder, or if it's a decimal number at all, then it's going to be a 1. Okay, so it'd be 4 remainder 1. We'll do 4 divided by 2, which is a clean 2. So it's 2 remainder 0. We're going to divide 2 by 2, which is going to be 1 remainder 0, and then we take that final 1 divided by 2, which is going to give us 0 remainder 1. Therefore, we've got 1, 0, 0, 1. So what we do is the first one, so that's the first number we did, the big one, goes there, 1, 0, 0, 1. Really simple. Now, you should have covered this already, but again, we're going to take a little look, just so you know. We've got a kilobyte, which is 1024 bytes. A megabyte is over 1 million bytes, and it just keeps getting bigger and bigger and bigger. Okay, you have essentially 1,000 kilobytes in a megabyte, 1,000 megabytes in a gigabyte, 1,000 gigabytes in a terabyte, and 1,000 terabytes in a petabyte. So that number gets really, really big, really, really quickly. So hexadecimal is going to be in the next video, but just so we're clear, we will be covering this again. But you've got your 1s column, your 16 column, 256, and that's about as big as it's going to get for your exam. So we times the numbers by the one at the top, just like you do in binary. To convert a binary number to hexadecimal, all we do is we split it into 2 nibbles. If the number's even bigger, you should keep splitting it. Say there's like 1 0 there, that just counts its own separate number. If there's only 2 numbers, you just add your 2 zeros like that. So this number here is 8 plus 1, which is 9. This one is 8 plus 2, which is 10. And if this was an example, that's just 2. So it'd be 2A9 for that example. You just split it up into groups of 4. So now we're going to take a look at some example exam questions, sort of run through how you tackle those. But a question like this is always going to be a denary number. It won't be a decimal for these kind of questions, but they come later on. We've got to convert it into an 8-bit binary number. So it's really simple. All we do is we take our number and we go, all right, 43 divided by 2 equals. So we know it's like 21.5. So that would mean it's 21 remainder 1. So if it's a whole division, it's remainder 0. If it's a decimal, it's remainder 1. Then we do that again. So 21 divided by 2 equals, and then that's going to be 10 remainder 1, and then we can already work it out, but 10 divided by 2 equals 5 remainder 0. 5 divided by 2 equals 2 remainder 1. So 2 times 2 is 4, plus 1 is 5. 2 divided by 2 equals 1 remainder 0, and 1 divided by 2 equals 0 remainder 1. Okay, now these numbers on the right correspond to the first, second, third, fourth, and so on grid, as it were. So if we do our grid as normal, so we do 1, 2, 4, 8, 16, 32, 64, and 128. This one goes there, so we've got 1, 1, 0, 1. So 1, 1, 0, 1, 0, 1. Okay. The rest of the number can just be zeros. So our final number is 0, 0, 1, 0, 1, 0, 1, 1. So if we add that up now, we've got 1 plus 2 equals 3, 11, 43. Therefore, that's worked. So that is our final answer, and that is how we get that. You're going to be given a binary number, which you've got to then convert into denary and hexadecimal. So we need to draw our grid. So we've got 128, we've got 64, 32, 16, 8, 4, 2, 1. Now I'll just draw some lines in. Don't need to do this, but especially working on a tablet, it's a little bit easier to read. Then what we need to do is go ahead and add those numbers in. So we've got 1, 2, 3, 4, 1, 2, 3, 4. So all we've got to do is add up any number that has a 1 in it. So we've got 128, we've got 64, 32, and we've got 16. Add them up as normal. So we've got 240. Okay, which makes sense because the maximum number you can get is 255 if every single one is filled in. For hexadecimal, it's much, much easier. So all we need to do is take this number 1, 1, 1, 1 and 0, 0, 0, 0. We convert this one to a hexadecimal number, which would be 0. This one to a number which is 15, because 8 plus 4 plus 2 plus 1 is 15. Convert that, which would be F. So your answer is F0. So we put F0 for that one and 240 for that one.